Hello and welcome to the 10th video in our series on using the equation editor in Blackboard Ultra. In this video we are going to examine the 9th tab, which is the Calculus tab, to see how to do typesetting with calculus operators and notation. So we go under the Insert Content, we go to Math, we'll go ahead and increase the font size here, and we go to this tab here, the Calculus tab. And in here we have our integrals, so we can have integrals with limits, so a definite integral if you will, an integral with a subscript. We can have an definite integral with the differential laid out, and we can have an integral with a subscript and a differential laid out. So if you put this one in and you go from A to B on the integral, and you have the big cursor here, notice that if I try to go in between here, I'm going to start getting those limits put up, maybe not where I want them. So let's go ahead and make sure that we're outside of this, and then we can do x dx if you want. So this is one way to do the definite integral. If you want to do the definite integral with the differential, we have more blanks to fill in, but it already puts the d in there. And notice the d is different. We have a standard d here as opposed to an italicized d for this one. So just that's more of a personal preference thing, I think. You can go ahead and have the definite integral with the differential already provided for you, or you can type it in yourself. When you have one with just the subscript, again, we're just going to put the subscript in here. This is normally used if you have sets, if you're integrating over a set of values used in measure theory, advanced analysis, things of that nature. And you can say that we have some kind of function here. So you can have that. Or, again, you can have the differential put in there as well. If you're integrating maybe along a contour curve in Calc 3 or vector calculus, where you would have x dx, you may want to be integrating over a curve C. So there are these notations available to you for calculus, and these are the integral notations. We could also have our standard differential if you wanted like dy equal to f of x dx. Again, this is usually used with differential notation when you're talking about increments. You could have this partial derivative, or a kind of a del operator in some cases, where you have f of xy partial x if you wanted to do that. You could also use the derivative notation common to Leibniz, who was able to generate this kind of ratio appearance with the differentials, where you could have some kind of differential equation set up with x being the dependent variable and t being the independent variable. You could also do a partial derivative notation if you wanted to do a multivariate calculus derivative using Leibniz notation. So those are your differentials. You could have the limit operator, where it's already defined where the variable would go to infinity. You may want to be careful here. Again, as you type, the subscript gets centered, whereas if you make sure that you're outside the limit little cursor box here, then the as x approaches infinity part stays underneath the limit name. You could also just have a limit as x approaches, so you go back to the arrow icon, x approaches 2 of f of x. And here again, my f of x is outside of that limit box, whereas if I move inside, my x approaches 2 part doesn't stay underneath. So again, you want to make sure that you are careful with where your cursor is so that your typesetting looks correct. Now here we have some vector operators. Here we have a curl, or basically the curl operator if you wanted to curl some kind of vector function, if you will. So you have the curl operator, you have the divergence operator, you could have the gradient operator if you needed it, or you could have the Laplacian operator if you needed it. So those are your kind of nabla operations right there. If you wanted to do a dot del, then you would have to go through and say, now I just need the nabla operator, which, if I remember correctly, is somewhere in the symbols. Trying to remember where it is. Let's see. There it is, the nabla. So you could do a dot del as well and get the advection operators done. So if you don't want the standard nabla operators here, you can use the rest of the symbols to get other operators based on the nabla. Here we have just a single integral, no limits on it, maybe an indefinite integral if you wanted to have that type set. You could have a double integral, common in Calc 2. You could have a contour integral, common in Calc 3. Or you could have a surface integral, which again is pretty common in Calc 3. So again, you can type these things out, using those notations. But here we have a little arrow that says more. Here you have your triple integral. And here you have your volume integral, or your kind of your triple contour integral if you needed it. Okay. So here you have your double and triple integrals as well as your contour integrals. These functions over here, these are your trig functions and your logarithm functions. So you can have sine of x, you could have cosine of x, you could have tangent of x. Now the drawback is that if you want the secant, cosecant, and cotangent, you have to hit the more arrow if you want those. Oops. So they are there, but you have to use the more arrow to get to them. And that's how you get to the other trig functions. So the popular ones, sine, cosine, and tangent, are already given to you. The other ones are over here under the more arrow. You could also have log of x. This is your common log. You could have log base. If I wanted log base 2 of x, you could have that as well. So let's go ahead and put that back up there. So if you wanted log base 2 of x or log base 5 of x, you could do it that way. And if you want the natural log, then you can get the natural log here under the calculus tab. The last three functions here are your inverse trigonometric functions. So here you can do inverse sine of y. Here you can do inverse cosine, I'll just say of y. And of course, you can also do the inverse tangent of y. Looks like we lost the y here. So your inverse trig functions are here. But if you wanted to do an inverse secant, okay, if you wanted to do an inverse secant, then you're going to have to type in secant, come here, do the exponent, and then type in what you have. So there's no inverse secant specific icon. You'd have to go through here, if you wanted to do the typesetting, you'd have to select your trig and then put the cursor between the name of the trig and the arguments going into it, hit the superscript, and then type in your information. And the same thing with the cotangent. If you wanted to do an inverse cotangent, you would have to split it up, go back to the algebra icon for the superscript, and then type in the -1 superscript attached to the name of the trig function to get these last three inverse trigonometric functions. And these are the commands that are located under the Calculus tab. And I thank you for your time and attention.